All right, hey everybody, welcome back to everyone in the class. Good afternoon, guys. So it's Monday, April 13th. This is our 1 to 2:15 p.m. Critical thinking class. Today we have another key lecture. We're going over chapter 12, and that's all about science. So once it's 1 o'clock, I'll take you guys through some of the notes on chapter 12, and then we'll be good for today. I hope you guys had a great weekend and are doing well overall and staying healthy and safe with the lockdown situation. Let me be right back. I'm just going to grab a tea and some eyeglasses. Okay. Cool. Welcome back. See a couple of you guys showing up so far. Got a couple minutes until the class time really gets going, so good to see everybody. We're at that point in the quarantine where I'm starting to get into my video game collection to try and pass some time. So I don't know if you guys are out there playing any games or if you had any recommendations, but I'm always happy to take those, especially during a couple of downtime minutes before class starts. I finally went back and got the. I've had the Nintendo Switch for a while, but I've just had like Mario Kart and Tetris 99 and the new Mario game, right? But I just bought the Zelda Breath of the Wild, so now I'm trying to mess around with that a little bit. I also bought the Goose game. I don't know if any of you guys have heard of the Untitled Goose game. It's kind of a silly little game, but it's actually pretty fun, and it won some developer awards and stuff last year. So if anybody knows what I'm talking about, if you know, you know. If you don't, you're like, what is he saying? But anyway, it's a fun game. I highly recommend try it out. If you like something that's not too crazy, not too long, but yeah, I bought it through the Nintendo Switch store. It's like $20, so not the best and not the worst price point. Anyways, it's chapter 12, and we still have 2 or 3 minutes till class, so I'm just patiently waiting for 1 o'clock. But anybody feel free to chime in, say a hello, or comment in any way if you'd like, and I'll see you guys commenting over there in the chat bar. Cool. Hey Priscilla, good to see you there. Anybody else want to say hi? Hello, good afternoon. Okay. Hey Walden, nice to see you. Hope you guys are doing well, enjoying the time at home if you can. Hopefully everyone's family members and friends are all staying healthy too. So far I've been very fortunate to not have any people that I know seriously ill or hospitalized or anything with this virus. So hoping we continue to have a good run of luck. Okay. All right, just another minute or so before I start off on these notes. Yes, I do have the Tetris game, Tetris 99. I'm a very good Tetris gamer, and yeah, I win some of those battles and stuff. I don't know if you have played it, but Tetris 99 is a lot of fun. It's made by some of the original developers of the original Tetris, so it kind of maintains a lot of the gameplay elements, but it's a couple of new features to it. It's kind of a battle mode Tetris game, a lot of fun. So yeah, I've also just been playing like old Tetris again on my Nintendo here at home, trying to surpass my old high score from 2010. I've had a couple of very good runs that are close, but it's just the most frustrating thing to me when I'm getting like a few points away, and then I just couldn't close close the deal and get those points. So anyway, I'll keep you guys updated if I happen to get a new high score. Anything over 600K would be great for me in Tetris. But yeah, Tetris. Also, I have PS4, Nintendo Switch, so I kind of want to get the new Doom game. I'm a big fan of the Doom series. If anybody's played Doom Eternal, you can let me know how it compares to the 2016 Doom game. All right, well, here we are, everyone. Welcome back. Great to see you guys, whoever's here gathered up and just watching this live stream. Couple of quick things to make mention of. Today was the due date of the current homework assignment, homework 3, the one that dealt with advertising and marketing, so finding fallacies basically in ads. If you haven't sent it to me, just make sure to send it over to me as an attached file. I've been receiving a lot of them, and I think probably have gotten most everyone from the class. But if you have not yet submitted it, I'll accept it as an on-time assignment if you can get it to me today. If it's late, then I'm going to have to deduct a few points for each day that it comes late. But basically, your best scenario would be to find a way to send me that file today if you have not yet already done it. And I'll be working on grading it, and I'll have the grades prepared and ready before next week. Next thing coming up after this is the quiz on Chapter 12. So the notes that we're learning about today for Chapter 12 and also Wednesday, they're going to be relevant to the quiz. So you have another quiz. It's the last quiz of the class. And then we've got down to just 3 more things. Quiz next Monday on science and Chapter 12. And there's one more homework assignment that I'm going to give you guys next week to work on. But hold off on the detailed instructions until next week. So basically you have a quiz, then there's that one more homework that I will give you details about next week, and then the final exam. So we're down to those last 3 things. One more quiz, one more homework, and then the last day is the exam. So just kind of keeping your mind on those subjects. The final is 20% of your grade, and the third quiz is a little more than the first 2. The first 2 quizzes were worth 50 points for 5% of your grade. The third quiz is worth 100 points for 10% of your grade, like a homework assignment. So there's 100 points for the quiz, 100 points for the 4th and final homework, and then 200 points possible for the final. So that means there's 400 points out there that remain outstanding. I haven't scored the homework that you just submitted, but prior to that, there were 500 points of yours that have been evaluated. And with this new homework you gave me, 600 out of 1,000 points in the class have been obtained maximum. So 3 more assignments to go, and that's how we split up the remaining 40% of the class grading basis. So still a chance for people to improve their scores or to hurt it a little if they didn't do anything with the last few assignments. Just a couple notes so that we are all on the same page. Anyway, turn your homework if you haven't done it, and be ready for the quiz next Monday. I keep saying Tuesday. I have another Tuesday, Thursday section in a different class meeting. But anyways, what are days anymore? It kind of gets confusing which day it even is. So it's Monday, April 13th, and we're going to talk a little bit about Chapter 12. Okay, everybody? So Chapter 12, another chapter in our textbook. We've gone over a lot of different stuff in this book. We learned about fallacies. We learned about the concept of knowledge, language and communication, basic qualities of a good critical thinker, deductive and inductive argument, advertising and marketing, right? Well, another important chapter of the book is this one, Chapter 12, and it's all about science and pseudoscience. So science, that's the topic of Chapter 12. Now, as many of the chapters begin, it kind of starts off with a little something to bring you into the topic and stimulate your interest in it a bit, make it a little more relatable. So they begin with the example of global warming. And, all the consensus scientific community point of view is that global warming is a big, major problem, right? That's growing in the scale and scope over time. Now, of course, this is written before the pandemic, but there's a lot of problems out there. So global warming is certainly one of them. And, according to the most reliable estimates of how things could go in the remaining part of the 21st century, sea levels may rise by as much as 7 inches or even a foot before the turn of the 21st century into 2100. So basically, greenhouse gases accumulate in the Earth's atmosphere as a byproduct of industrial processes and the consumption of carbon fuels. Those trapped greenhouse gases over time produce a greenhouse effect that causes the planet to heat up a little bit. And you can sort of plot a graph which shows global temperatures spiking as we get later and later into the historical time period leading to the current day. And that seems to be related, obviously, to the advance of human industrialization and also energy production around the world and consumption. So this heating trend of the planet seems to be accelerating. If you look at the data, in the last 10 years, 2010 to 2020, we've had all the hottest years that have ever been measured since we started doing measurements back in 1850. So like all of the hottest years globally are all clustered to the tail end of the timeline of history, showing that there's an increasing trend. And water levels are rising because of the melting Arctic sea ice, which is a byproduct of this heating phenomenon. So the sea level rise is a big concern, right? Because in a worst case scenario, if you've not had too much of those lately, in a worst case scenario, you can have coastal regions that are submerged underwater because of the effect of advancing sea level. And we, of course, living here in California, are pretty well close to a coastal region, if not directly. So it's something that has the potential to have major impacts on civilization, infrastructure, and our lives, certainly our children and grandchildren's lives if we have those. So as critical thinkers, we need to be able to evaluate and interpret information that we find from science, both when it's found in scientific forum of publication, also just the media, and how to research scientific questions. So in this chapter and in the lessons that follow today and Wednesday, we're going to learn a little bit about the history of science. We're going to identify what are some of the most basic assumptions that science makes as a field. We're going to talk a little bit about the steps of the scientific method. So we're going to review that concept that maybe some of us have learned earlier in our high school or even elementary school science lessons. And we're also going to learn a little bit about what the difference is between authentic science and then pseudoscience, which is like junk or fake science. So let's begin, I guess, with a clear definition of the concept of science itself. So what is science overall? Here's how the textbook defines it. It's reasoning from observable facts to testable explanations for those facts. Okay, so that's what scientific research and scientific inquiry is all about. Starting with observing the world. So the scientist, the researcher, just observes the world and collects data about it. They notice facts, they notice that things happen, and they want to be able to explain the reason for those events that are happening. They want to be able to provide explanations for those events that are so clear that you could even generate tests to establish whether that's the correct explanation or not. So like just for example, right? Take human beings living in previous periods of human history. At one point in time, like let's imagine a volcano erupts. People can see the volcano erupting, they see the lava, the magma that's ejected from it, and the subsequent effects that it has on the surrounding environment. Now it's just a fact that the volcano erupt, right? So they observe this using the five senses, vision and whatever other senses exist. But if you're a scientist, you don't just want to say, look, something happened. A big mountain started blowing out magma. You want to know why it happens, right? You want to be able to explain the reasons so that perhaps you can model the occurrence of this happening in the future. And if you know what the causal reasons are, what the factors are that lead to it happening, then you'll be able to better prepare for it and you'll be able to understand when it's likely to recur, under what conditions, right? So scientists want to know what the reasons are for the facts that they observe. So they see the world, they see facts within it, and they try and supply explanations for those facts that could be tested for accuracy. Okay, so that's the concept of science. It's all based on observation of the world, looking at the things that occur within it, and then attempting to provide some kind of coherent explanation or justification for why the event did happen. The explanation that is given is again thought to be something that could be tested for its accuracy by other people. And so in science, they never say, just take my word for it, here's what I'm telling you, and don't you question it. Instead, they say, no, if you don't believe this explanation is correct, then here's a test that you can perform to verify for yourself. So it's all about observation, explanation, and test. Science is therefore the major source and method for getting information and knowledge about the world. If there's anything you want to know about this world, how things operate, how things work, what the cause-effect relations are between events, then science would be the best place for you to go to get your answers. Why does a plant produce materials that it can sustain itself with? What is the process of photosynthesis? How does the circulatory system work? How does the process of respiration on the planet, the weather cycle, work? What is the process of reproduction, nuclear fission, fusion? How does light propagate in a vacuum? Any question at all under the sun that you can think of which you would like to pursue an interesting and clear answer for, science would be the best place for you to find that answer. So it's important to us as human beings. It's kind of in a way what distinguishes us from other animals, also together with language and culture, but science is the domain within which we pursue answers to the biggest and most important questions. Sometimes the answers to these questions serve practical value, like the development of new technologies that help make our lives easier. Sometimes it's merely for theoretical value, to have knowledge. Like, for example, if you know how the parallax effect works so that you can measure the distance of very distant stars from the surface of the Earth, you're just getting knowledge about how far the objects are. Maybe that's not something that you'll ever be able to do anything with in terms of a practical result, unless I guess you're a scientist who is commissioned to do such research, and that's how you pay your salary. But for the most part, that knowledge that you get might not have practical value, but it's of great value epistemically, just in terms of the knowledge itself. Now, we're living in the 21st century. It's 2020 right now, and we've all been huge beneficiaries of the so-called scientific revolution. If you'd lived 1,000 years ago, there wouldn't have been anywhere, of course, near as many technologies, medicines, and applications to make more efficient your life as a human being. So we're all the great beneficiaries of science. We therefore owe a great debt of gratitude toward it. But it hasn't always been this way. Prior to around the 17th century, and prior to the Renaissance period in Europe, the church was said to be the sole source of all truth in the Western world, and really globally for the most part. So if you ever had said anything prior to that time period of Renaissance and then following on 16th, 17th century, if you had ever said anything that contradicted orthodox views of the church, you could have been persecuted for that. And certain early scientists and researchers were in fact persecuted. So there's some important figures I'd like to mention that are talked about in the book. Early important figures of Western science. So one of them is this man, Copernicus. Make sure I'm spelling his name right. I always forget, is it an E or is it a U? I'm going to double check. Yeah, E. Nicholas Copernicus. So who was this man? He was, first of all, he lived from 1473 until 1543. So that's a 70-year lifespan. And he was a Polish astronomer who discovered the heliocentric model of the solar system. Okay, so main important aspect of his contribution to the world was the discovery of what's called the heliocentric model of the solar system. Does anybody have a thought or knowledge about what the word heliocentric means? What does it mean that he discovered heliocentrism? What thing then do you imagine he did find or discover? Heliocentric. I think maybe some of you can have at least a reasonable guess as to what that is all about. What do you think? He discovered the solar system is heliocentric. What could that mean? What does that mean? What do you think? While you're thinking about it, I'm going to add one little piece to this description to give you a hint. Okay, so a Polish astronomer who discovered the heliocentric model of the solar system, comma, let's add a comma, which replaced the geocentric model. Okay, correct, exactly, Thomas and Matt and Sergio and whoever else is on the right track. He discovered that it's the sun that's at the center of our local cosmos, and that the planets revolve and rotate around the sun. Prior to Copernicus, the belief that people had was geocentrism, which means earth-centered. And one reason, in fact, the main reason that geocentrism was very important to people prior to Copernicus and Galileo, who also was using newly invented telescopes to arrive at the same results. Galileo Copernicus discovered that the Earth's not in the center because they were able to just use telescopes to watch the motions and orbits of the celestial bodies, and they could use that to deduce the correct outcome, that it's the planets that orbit the sun, not the other way around. But why was it so important to people to believe that the Earth was at the center of everything? Well, it was really out of deference to church orthodoxy, because it had been believed in the early church that God, right, created the universe. And since God created the universe, he creates it with mankind foremost in mind. The doctrine of religion claims that we are created in God's image, not that we naturally evolved through like a chance sequence of events, but that we were designed by God in his image, and the whole universe has been put here just for us to inhabit it. So if God made the world for the sake of man, then you would expect that we would have pride of place, so that the planet that we live on would be in the middle of everything, and everything else would revolve around it. So that had been a very important doctrine of early church. And when Copernicus and Galileo used these new telescopes to find otherwise, they were persecuted for having said so. In fact, Galileo, for example, was forced to recant his testimony, meaning he had to take it back in public. Otherwise, they said that they would execute him, even though he was very old and half blind because he'd been looking at the sun through telescopes too much. And so even later on, centuries later, in the 20th century, the church issued a formal apology to Galileo and his descendants, because it's now understood by all and uncontroverted by anybody that the Earth does rotate around the sun, and we're not in the middle. But just that simple idea that you could determine by using real observations of the night sky, that in itself was considered so heretical and unorthodox that people would be punished, excommunicated, persecuted, even executed if they had held those views in public. Now, of course, as time passes, we learned that the scientific account of this was actually correct. There were some loyalists to the church, though, that tried to invent other models to continue to prop up the idea that the Earth was at the middle of everything. One of those other figures is this man named Ptolemy, the silent P at the beginning of his name. Ptolemy was loyal to the church, and he tried to invent a model according to which the Earth was at the center. But the only way that that assumption could be sustained, given the observations being conducted with telescopes, would be to assume that the other planets and sun rotate around us in these corkscrew-like curlicues, which they called epicycles. Now, we know from the work of Johannes Kepler and others that this is not true, that objects in space orbit around each other in smooth ellipses as they free fall through space, held in gravitational attraction by the mass of the object that they revolve around. But in order to withstand the assumption that the Earth's at the middle, they had to interpret the data they were seeing as though we're at a fixed point and everything goes around us in these, inelegant non-parsimonious corkscrew patterns. But anyway, we're not so confused about this any longer. So that's one major contribution from the Renaissance and Age of Reason that we derive from Copernicus, and to some extent Galileo. He's also mentioned as another figure somewhat contemporaneous with Copernicus, meaning around the same time, who had the same kind of results. So that's one piece of notes. I'm going to erase that, and I'm going to mention to you guys one other important figure from early Western science. There's so many, it would be impossible to list every name, but there's a couple prominent figures that they did want to mention in the text. So another one is this man named Sir Francis Bacon. Okay, so Sir Francis Bacon, the British man who lived from 1561 until 1626, and his contribution was the establishment of the steps in the scientific method. So Sir Francis Bacon is the person who can take credit for the familiar procedure that many of us have learned about in school, known as the scientific method. So he said, if you want to determine the answer to a scientific question, then you should proceed in the order of observing some problem that needs to be explained, formulating a hypothesis which attempts to explain the occurrence of the observed problem, and then to design some test which could be used to determine whether the hypothesis was true or not. So observation, hypothesis, and testing, the steps of the scientific method, can be derived from writings and ideas of Sir Francis Bacon. At one time, during the time period that he lived, for example, so like when rotten food would be left out and maggots would come later to like feast on the rotting food, some people in his time and age believed that the maggots actually were the result of the food transforming itself into maggots. Like they didn't believe the maggots came from like larval deposits of passing insects, because I guess they weren't studying the food, 24/7, and so they leave it sitting out, come back like a day later, see that it's been consumed by these little bugs, and some people actually believe that the bugs were, and see if both would mutate into maggots or not. And of course, when that conducted experiment happened, using the controlled variable of the barrier being placed around the food, it was able to be determined that, contrary to what many people thought as a popular belief, no, they will not generate maggots of themselves unless they're exposed to some kind of environmental passing by insect. So the ones contained within an impermeable barrier never exhibited maggots, as opposed to the others. So anyway, questions like how does this work? What is the causal basis for some phenomena can be pursued through scientific method. And Francis Bacon is well known for having stated the steps in that method. Okay, so just a couple of opening notes on some figures of importance in early science and just the definition of it itself. The next thing then we're going to talk about here are some assumptions that are found within science. So these are like core assumptions that have to be made for scientific practice to even exist. So what are some of the assumptions behind science? Okay, so one of these is the assumption of empiricism. Now, this is not actually the first time that we've encountered the term empiricism. We briefly discussed it earlier in the semester when we were learning about knowledge, when we said that there were these two different rival schools of thought about where most human knowledge comes from. There's rationalism and then empiricism. So the definition's already in our mind and in our notes. It's coming back into play here because it's also an important concept for scientific process. What is the belief of empiricism? It says that most human knowledge comes from what again? Just a quick reminder. Empiricism says most human knowledge comes from where? Question. What do you remember about that? Where does most of it come from, according to this position? Most of it comes from where? Let's see. No, Walden, that's the other one. Okay, we're getting confused. Rationalism is the one that says most human knowledge comes from abstract thought, pure ideas, and rational abstract thought. So no, it's not that one. So what's the other one? Empiricism, to get the correct answer, is the belief that most human knowledge comes from experience. The key term is observation based on the five senses. So let's all make sure we don't forget that. Empiricism, most human knowledge comes from the five senses and observation. Okay, so that is, good job, guys. Thank you for your help. That is the key idea of empiricism. The most human knowledge comes from the five senses and the observations that we can perform by means of them. The five senses, now we remember sight, taste, touch, hearing, and smell. And those perceptual abilities, according to empiricism, they give us most of our knowledge about the way the world works and what's going on in it. So why is that a basic assumption of science? Because science, as we have said, is all about observing the world and then trying to provide testable explanations for the things that are observed. So it all starts with observation. Scientific process and method is defined by empirical investigation into the world, looking at the world using our five senses and also whatever tools that we can build which can enhance the five senses. Like, for example, a telescope or a microscope is to augment the power of vision, just like a stethoscope is there to augment the power of hearing. So with our five senses and indirectly by means of them through instruments, we can obtain a lot of wealth of information about the world. And since science is all based on observation, it holds empiricism as a fundamental baseline assumption. Okay, so that's one big assumption of science, the view of empiricism, which prioritizes the physical five senses as a primary source of human knowledge. Another assumption of science mentioned in the book is objectivity. Okay, objectivity. What this word refers to is the belief that we can study the physical world and learn about it as it really is with no bias. So the belief that we can learn about the physical world as it really is and with no bias. That's another basic core assumption built into the practice of science. So objectivity. This is a word that I'm introducing here in our class because it's referred to in our text, but it's also, there's Kitty there, it's also one of those words that I think you probably have some basic assessment or understanding of from your own life and experience. So let me give you a quick question to sort of see where your overall vocabulary is concerning this word. Objective, the word objective, is oftentimes compared and contrasted against the word subjective. Okay, yeah, she's a really good kitty. So, like, for example, let's throw one question out there at you. If I tell you that vanilla is the best ice cream flavor, would you say that is an objective or a subjective statement? To say vanilla is the best ice cream. Is that objective or is that subjective? Wonder what you think. Which one? Question is, it's subjective, right, exactly. Why is that subjective? Well, because it just depends on my own personal opinion. It's sort of not an objective fact because it's different for every person. I may think it's the best, but that doesn't mean that in some objective sense, you know, it's really the best, okay? But if I say another statement like, let's see, Cal State Fullerton is located in California. Is that subjective or is that objective? It's objective. It's not just how I'm feeling or related to my own perspective or personal point of view. It's a fact that has nothing to do with me, the individual. It's an objective fact that's independent of my mind. Or like if I say the moon exists, is that subjective or is that objective? That's an objective fact. At least we assume that there is an objective reality that we're capable of studying and capable of learning about in and of itself. So scientists believe that when we make scientific theories that get to the truth, that we're not just talking about our feelings and thoughts in our head, but that we're actually getting to the truth of how the world objectively is in and of itself. So a scientist who comes up with like a correct theory of gravitational attraction doesn't think that they're describing the mental behavior of their brain, but rather they're explaining the actual physical operation of gravity in space independently of the person. So science claims the ability to pursue objective truth, that there really is an objective world out there which has some definite nature that we can come to discover using reason and the tools of observation. If there was no ability to learn about the objective world, like if we thought we will never get to the facts of how things really are, all we will ever do is talk about how things seem to us, then there would be kind of no point, because science claims to be deriving knowledge and facts about reality, not just about the inner association of ideas in your mind. So two big assumptions of science that we put so far on the table. Number one, that by means of using our observation and 5 senses, we can figure out knowledge about the world. Number two, the knowledge that we get to by means of our scientific investigation is objectively real, and it's not just something that is a reflection of a person's perspective or bias, okay? So that's the second point of view that's assumed in science. Okay, so third, and I'm going to continue on the same theme, assumptions behind science, so we have more of those. We've talked about empiricism and objectivity. Another main assumption within science is this one, which is called the assumption of materialism. Okay, materialism. This is the belief that everything in the universe is made out of physical matter, including us and our consciousness. Okay, so I'll make sure you can see it once I write it, that I'll have to move Kitty, but for the time being anyway. including us and our consciousness, you know, our mind and thoughts. Okay, so allow me to repeat the definition and maybe, come on, Katie, can we move a little bit over here? Sorry for that. Okay. Anyway, you know, she's a good girl. She's always getting involved in my lectures, I guess, now that we're doing live streams. But back to this. Materialism, as you see it written here, it's the belief that everything in the universe, not just some things in the universe, not just like most of them or a couple of them, but literally everything, 100% of everything is made out of physical matter, including us, including our consciousness. Okay, so what is the most fundamental unit of matter, if you could think about that question? You know, everything's made out of a specific type of little physical building block. What's the term in science of the most fundamental thing that makes all things up? It's all just made out of, what is this building block? Atoms. Good, Priscilla. The word is atoms. The word atom originally came from Greek. And it refers to the prefix a, meaning not, and tome had to do with the concept of being able to cut. So an atom is thought of as something that's not further subdivisible into more small parts. So uncuttable is the ancient Greek meaning of the term atom, where it derives from. But yeah, these tiny little physical bits called atoms. Now, nowadays, we actually sometimes speak of subatomic particles like quarks. But at some level of reality, there's a basic minute element. Call it an atom for the sake of brevity. According to this view, everything's made out of atoms. It's not just some things, but everything. And where this becomes a little bit more controversial or interesting is the claim that it's also the mind that's made out of matter as well. So, you know, what you're feeling and thinking, if you right now form an idea in the mind, or if you have dreams, any feeling, state of emotion, or mental process is, according to this view, just a process of the physical brain, which is made out of mass. So according to this perspective, there's no such thing as an immaterial soul. There's no non-physical substance that can exist if it's not made out of matter. So, I mean, according to materialism, there could not be, let's say, like a disembodied consciousness, like a ghost, because there would be no material basis for it. So according to materialistic thought, the only way that consciousness could arise is within the physical system of the brain. And therefore, if there were no brain, or if the brain were destroyed, then consciousness would be destroyed along with it. So it's, you know, it's contrary to any belief in the soul, the spirit, or disembodied consciousness like you might have in the case of an afterlife or a ghost. The word materialism is also sometimes associated with a different meaning of the concept. Remember earlier we talked about equivocation, where a single word can have multiple meanings, like I don't know, bank could be a river bank, or it could be a financial bank. Materialism is defined in this context as the view you see here. But sometimes people use the word in a completely different sense, and I don't want you to be misled or confused. Sometimes people speak of materialism and they talk about a person who just cares about their looks, or about the things that they own, or the way that they think other people perceive them. You know, so like a materialistic person might want to really always, you know, flex with like the nicest outfit or something, or to be seen in the nicest car. But this has nothing to do with that. The scientific and philosophical usage of the term simply refers to the belief that everything's made out of matter. So materialistic, in the sense of physical material, is the only thing that exists. Everything's made out of matter, and there is not one thing that is not made out of matter. So there's no such thing as a non-physical object, or an object that exists but it's not made out of atoms. Okay, that's another assumption that's held in science, because if there were things that were not physical, then they would escape the capacity of being observable. And in that case, they would remain permanently immune to scientific explanation. So scientists believe they'll be able to explain everything through empirical research. Not that there's some mysterious things that will forever be left untouched because they're outside the realm of the physical. So it's kind of denying the existence of supernatural entities, or purely spiritual entities that are not based on physical matter. Okay, just another idea of a major assumption in science. So we're going to continue. I got a few more of these points to raise in the discussion of chapter 12. How's it going, Kitty? Okay, so the next one is the term predictability. Okay. Okay, so the scientific assumption of predictability is the belief that the world, the universe in other words, is orderly and predictable. So established cause-effect relationships will be repeatable and will hold forever. Okay. So established cause-effect relations will be repeatable and will hold forever. That's the assumption of predictability in science. It's another fundamental cornerstone of the whole enterprise. And it says there, as you can read, the assumption is that the universe, the whole system, the entire thing, the universe is orderly and predictable, meaning that established cause-effect relationships will be repeatable and then they will hold forever. Okay, so for example, I'm holding this marker suspended in the air from this position above the table. It's in my grasp of my hand, right? But what I'm about to do is release my grasp. I haven't done it yet, obviously. We're waiting for me to do that, but right now it's being held. Nonetheless, when I release my grasp, what do you predict would happen if I release my grasp of this marker above this table? What do you think would happen? What's your prediction there? What is your prediction? It's easy enough, but let's see you put it out there. I've got the marker, I'm holding it, but I'm not going to keep holding it. I'm going to open my hand. You say we'll fall and hit the table. How do you know, though? I haven't done it yet. So what are you basing that on? What makes you so sure? What's the reason? I mean, I haven't even dropped it yet. So how do you really know it's going to fall? It's kind of a trick question, but I do want you to think about it and say what you would give me as an answer. Well, you're saying gravity, but gravity worked before. What makes you think it's going to work today? I mean, it used to work, but how about it stops right now? You're saying the word gravity, but what makes you think gravity is going to continue working? You haven't seen me drop it yet. Maybe now is the moment gravity's going to stop working. So how do you know that won't happen? Scratch your head, think about this. How do you know gravity's going to continue working? Or what makes you think it's going to continue working? You already said it worked before. That's been established. I'm talking about the next time I release it, not what happened before. This is live right now. So why do you think gravity will kick in again instead of taking a break? What makes you think it will work again in this new case? Because I haven't opened my hand yet, so we really haven't seen what will happen. What makes you think so? Well, I didn't want you to be that stumped, Walden. I mean, I'm trying to mess with you a little bit, but the point I'm making is you assume that it's going to continue happening the way it always has in the past, because basically that's just a brute assumption of science, that when we have established cause-effect connections, we believe that they're going to repeat on and on and on into the future forever. Okay, so let's experiment. Just as predicted, it fell. Now, what makes us so sure that the process of gravity will continue to repeat in each new case where a gravitational effect could be observed? It's because we think that these laws of nature are not for the time being. We think that gravity and other such natural laws aren't just for now and for here, but for all times and places. So if I had infinity of time to spend and I could just keep opening my grasp here over and over again after I pick the marker back up, how many times do you think this would continue to fall in the same way on and on into the future? And I'm thinking, based on your responses before, that you would guess this is going to happen permanently, that there would never be one case where I open my hand and instead of it falling down, it free floats or turns into a chicken and flies off or something, right? You assume that that will never happen, even though you haven't seen the future yet, and I guess you haven't got 100% certainty about how things will play out. But what you assume is that the laws of nature will persist in the future in the same way they have in the past, and that if we had created identical conditions in a closed physical system, then the same effects would be observed there. So if there was another planet of identical size and gravitational mass as our own, then on that planet, an object dropped from a freestanding height should fall as well, right? Because we think that these laws don't only operate for a limited scope of space or time, but that they operate in the same identical way across all times and places throughout the whole universe. So scientists assume that as well. They assume that the conclusions that they derive from their research are conclusions that will hold not just for here and now, but for there and then, for everywhere and every when. Okay? So it's like we don't have to really sit for infinity of time and watch me keep dropping the marker to come to our conclusion that this would continue happening permanently. Because it's just an assumption of science that the laws are stable and that they don't permit of exceptions either in time or in space. Okay, so another big baseline assumption of science, that the universe is predictable. So what's going to happen next isn't just a mystery. When I've explained the cause-effect relationship between the cause and the effect, when those causal conditions exist, the effect will reliably follow from it. And that's not just in the case of gravity, but anything else, right? Like if I had identified the causal basis for a volcano, then I would be able to establish that when those conditions recur, that a volcano will be the byproduct, the effect of those conditions that precede it. Okay? All right, so another big assumption of science that we put on the table and discussed. Okay, and just checking time, we're doing well. So one more main assumption of science is the last one listed in the book, and that's what's called unity. The assumption of unity within science. So this assumption holds that there's an underlying unity to the universe such that everything can be explained according to a single universal set of scientific laws. Okay, so the belief that there is an underlying unity to the universe, such that everything can be explained according to a single set of scientific laws. Okay, unity to the universe, so everything can be explained by a single set of science laws. That's this last assumption mentioned here of unity in the field of science. So what scientists believe, and this is kind of like an aspirational hope of science, it's the belief that the universe we live in operates on one set of laws and principles, and that eventually, even though we haven't quite done it yet, that eventually we will discover what that grand unified theory of reality is. In fact, that's even what it is sometimes called as an abbreviation, GUT, Grand Unified Theory. And that this comprehensive theory of reality would be able to explain every event from the largest to the smallest events. So all the way up to the biggest galaxy superclusters and the behavior of macroscopic phenomena like that, all the way down to the behavior of tiny little quantum particles at the most infinitesimal microscopic level of reality. So scientists presuppose or assume that eventually, as we continue to make scientific progress, we will eventually establish a coherent set of scientific laws and physical principles that could explain everything that ever happens. We haven't quite gotten there yet as of today, because there are two main paradigms in theoretical explanation in science that are not exactly consistent with each other at the margin. So for example, to explain the biggest macroscopic phenomena of scientific description, we use the theories of Einstein and the general and special theory of relativity. But to explain the behavior of quantum particles and phenomena, the smallest things, we instead utilize quantum physics and quantum theory. Now, that's one set of principles for the big stuff and another set of principles and laws for the tiny small things. And they don't exactly agree those two fields of explanation. So the hoped for outcome in the future is that we will eventually have something that can integrate and make consistent the two fields of relativity and quantum theory. But as of right now, that's still a project for future scientists to successfully achieve. So the hoped for unified theory is still waiting in the wings, but scientists assume that we will get there. And the reason, again, is because they think that it would be bizarre if there were two different sets of laws that explain reality, one set of natural laws for the small things and another one for the larger things. So given the belief that we live in one world and one universe, there has to be, so it is assumed, one core set of physical principles that when they are discovered will be revealing of all explanations. Okay? So we've talked then about the so-called assumptions behind science. Now we move to the next little section of chapter 12, which goes over what are called limitations of science. So let me talk to you about those points really briefly. Okay, so limitations of science. Okay, so as important as science is and as necessary as it is to explain the nature of reality and the circumstances of the universe, there are some limitations that it has, some things that it basically is not able to fully figure out, or at least obstacles to its practice that it can't overcome. So here are some basic fundamental limitations of science. I'm going to sort of just talk through some of these points because I didn't want to make too much detailed notes to throw you off, because some of it's quite philosophical and esoteric. But let's mention this one just in conversation. One limitation of science is that it assumes that the external world exists outside of your mind, which cannot actually be proven. Okay? Now, you right now take yourself to be looking at the computer screen, watching this live stream, or if you're watching it on a tape delay later, watching the replayed lecture. And you assume that there's this world that surrounds you, that you're a student at Cal State Fullerton, and you're right now sheltering at home because of the COVID-19 virus that's unleashed a pandemic on the world. But how do you know that all of those things are really happening and you're not just dreaming, right? We talked about Descartes a little while back in the semester, and the method of doubt, which assumes, things are false if they can't be proven beyond all possibility of doubt. And the possibility that you're experiencing a very realistic dream right now is something I guess you cannot completely rule out. Imagine if you were right now living in a computer simulation, and so although you think you're in the real objective world, you're actually just dreaming the whole thing, or being stimulated to believe these things by a computer programmer in another level of reality that you don't have access to. I guess you cannot definitively rule out these very far out scenarios, right? Because if you were right now in the midst of a simulation or a dream, then the information available to you to determine whether it was a dream or not would be just like this. If it was a good enough simulation, of course, the whole point would be that it would trick you, just like in Inception or The Matrix or other films with that kind of plot line. So science, of course, assumes that there is an objective world, that when we study it, we're studying things that are outside of our mind, that are out there and that are independent of the mind. But there's no absolute way to guarantee that the world that you appear to perceive is objectively real. Nonetheless, science has to make that assumption. So one limitation of science is that it's forced to make the assumption of the existence of the external world, which cannot be proven beyond all possibility of doubt. Nonetheless, I don't take that to be the most significant limitation of science, because almost nobody, I think, would take very seriously the idea that the world actually is a big illusion, hologram, or dream. So if it's a limitation, it's not one that I think bothers too many people, because it's just kind of hard to take too seriously the postulate that there's no external world and you're just dreaming everything. Okay, another limitation of science, I'll put that here really briefly, assumes external world exists. And by the way, think about that, right? Like, we have to assume the external world exists, because if we didn't, what would be even the point of learning about it? I mean, imagine if Mario, like in the Mario Brothers universe, wanted to start conducting scientific experiments to see, like, how does, you know, those green pipes that I go down, how do they actually function? Is there a gravitational force that sucks me down through the pipe, or is it just the mass of my body that falls to the pipe? There'd be no point for Mario in the Mario world to learn those things, because his world isn't even the real world. So whatever knowledge he finds is just knowledge about a simulated world. If you're living in a simulation right now, then the work of scientists is just kind of pointless, because they're only discovering facts about a world that's a dream world. So anyway, science assumes clearly otherwise, that there is in fact an objective world we're capable of studying and learning about, and that's the subject matter of our scientific investigations. Another limitation of science is that it's only able to discuss the things that are observable. Can only discuss or, you know, evaluate that which is observable. So if there was something that was not even indirectly observable, then that would be very mysterious for science, and it would perhaps remain closed off to scientific explanation. So science has a hard time understanding things that cannot be perceived. Like, for example, all matter in the universe appears to be speeding away from all other matter. Basically, the concentration of mass is getting gradually less and less dense over time. And it appears that there's an outward expansion of the universe from a central point, such that everything is now getting farther and farther away from everything else. Now, what is driving this outward expansion of material? You'd think that the force of gravity would tend to cause a contraction, because mass tends to attract other mass, and massive objects have gravitational attraction. What could explain the existence of this outward propulsion of all matter if gravity counteracts that force? There's not a clear scientific explanation, but one theory is that there's such a thing as dark matter, and dark matter somehow fuels the expansion of all material from everything else. But the thing about dark matter is it's called dark matter for the exact reason that it's not perceptible by any indirect or even direct or indirect means. So the existence of a thing such as dark matter might serve as an explanatory postulate to explain the cause of all matter becoming less dense. But since it's something that is inherently unobservable, it's very tricky for science to be able to make any assessment of those claims. So another limitation of science, just mentioning it, is that it has a hard time talking about things that cannot be observed. If there are such things, science is going to have difficulty because it can only make theories based on things which are observable. And then the last thing is that some people critique the whole predictability assumption of science, right? Science assumes that the operation of natural law will continue on in the same way as it always has before, and that will never change. But since we've never experienced the future yet, some criticize this limitation of science, that it assumes the stability of natural laws into the future, which of course can only be assumed but not proven until the future happens, which of course by definition, the future's in the future. Okay, so that was my little spiel about a couple of important limits of science. The next part of chapter 12 talks about attitudes that people take toward the tension between religion and science. Since we're on the subject of science, I'm sure many of you guys know that like a lot of people claim that science and religion don't sit well together, that they contradict each other, that science makes claims that are inconsistent with traditional religious views, or vice versa, that religion makes claims that are contradicted by scientific evidence and research. What is a person supposed to do when what the scientists and what the theologians say are different and even incompatible? Well, the textbook mentions 4 attitudes that one can take toward the relationship of science and religion. So 4 attitudes about the relationship or relation between science and religion. Okay, so one of these views is the view that science takes priority over religion when they come into conflict. Okay, that's one view. And I'm just going to write the views here first and see, how much time is left in the class period when that's done. And then depending on how much time it did take, I'll either go over a few of them or we'll save it for the top of Wednesday. Okay, so one view is that when science and religion clash, when they don't agree, some people take the viewpoint that science should be prioritized or deferred to in that kind of case. A second possible attitude or position is that the opposite. Religion takes priority over science when they conflict. That's another view. That would be the view that if science and religion don't agree, instead of going with the scientific answer, this type of attitude would hold that you prioritize and go with the religious answer and reject the scientific claim. Okay? A third possibility mentioned is that science and religion are dealing with different topics, and therefore they actually don't come into conflict. So that's 3. Science and religion deal with different topics. Science and religion deal with different topics. That's a third viewpoint. Some people would claim that although science and religion appear to fight or disagree, that they really don't. That's just an illusion. In fact, they're not even talking about the same stuff. One might argue that science talks about material processes and cause and effect relations in the universe, whereas religion deals with moral questions and spiritual questions that are not at all involved in analyzing cause-effect connections of reality. So some people say they're in their separate lanes, as it were. They're not overstepping each other's boundaries. Religion deals with subject matter that science doesn't, and the same goes the other way. Now the fourth view, since I ran out of space on the board, I'll put it up here. I mean, it doesn't matter how they're numbered, but I'm just going to number it anyway so that we sort of see that it was the bottom one in the text. The fourth one is that science and religion are compatible. So they're actually, they agree and they say the same thing if you really analyze them the right way. So science and religion are compatible. So according to this fourth viewpoint, they're not on different topics, but what they say is agreeing with each other. Maybe if you interpret the religious claims in the proper way, you would see that they actually don't say anything different than the scientists. So those are 4 viewpoints. Basically, the difference between them is this one says you prefer science over religion when they don't agree. In this case, you prefer religion over science when they don't agree. In the third case, you say, well, there's no real disagreement because they're not even talking about the same stuff. One talks about morality and the spiritual, and the other talks about the physical and cause and effect. And in the fourth case, the idea is they aren't really disagreeing because they come to the same conclusions. Maybe they say them in different language, but what they ultimately say is the same thing. So let me give you an example that we can use to discuss these different attitudes. Take, for example, I don't know, the hypothesis of creationism versus evolution. Okay, so what science says is that we naturally evolve from similar life forms over a very gradual process of change that spans eons of time. Not that we were created wholly in God's image immediately, but that Homo sapiens are a descendant of intermediate species of higher apes that gradually became bipedal and more human-like and so on, right? So that's like the scientific explanation according to Darwin's theory of evolution. And there's, significant data to back that up, like the fossil record and carbon dating, okay? But of course, certain stripe of religious believer could claim, no, that's false. God created us in his own image within the first 7 days of creation. So that's definitely a different claim than saying billions of years passed in the universe as evolution took its course and mankind slowly took form. So what's the answer? Is it the scientific answer or the religious answer? According to this first viewpoint, the person would go with the science answer. They would say, okay, well, religion says there's creationism, but science contradicts that. So science is the one to be preferred here. Take the second viewpoint, though. This would be the alternative. So this would be like the scientific realist who rejects religious claims when they conflict with science. This would be like more the devout religious practitioner who says that scientific claims are to be rejected when they conflict with religious ideas. So in the view of the debate between creationism and evolution, the individual with this attitude would say, no, it's creationism that I have to hold on to, and somehow these scientists are just wrong, either misinformed or incorrect in their conclusion. The third view here would hold that science and religion are not talking about the same subject, that religion is where we go for moral instruction and to get a sense of the divine, but in science we just see cause-effect explanations of physical phenomena. Some people would like to cordon them off in their own separate spheres, but in a way it's hard not to see that little overlapping sliver as in a Venn diagram where both circles intersect, because clearly they at least appear on the surface to talk about similar things in some cases, right? In the book of Genesis, the Bible offers a story about how the universe was created and the creation of man. But that's different from what is claimed by natural scientists who say that this all happened naturalistically over a much longer time period. So although both seem to be talking about the nature of the universe, its origins, and the origins of man, this would claim that they're not on the same topic. So sometimes it's hard to see this being too sustainable. The final attitude would be that they're compatible with each other. And so sometimes when people hold that fourth viewpoint there, they will say something like this: it only seems like the two areas disagree because you're applying the wrong interpretation toward the scripture. So in the Bible, in Genesis, where it says God created everything in 7 days, some people will say, well, okay, science says that's not how it happened at all, that it took billions of years for even, matter to coalesce into the stars and planets that later on would provide the conditions for life. So what's the answer? Is it 7 days, or is it billions of years that it took for mankind to come into existence? Some would say, well, there's no disagreement here. It just looks like it. The real answer is that when the Bible says God created the universe in 7 days, how do you think someone could finesse making these two things consistent with each other? The answer from science, that it's billions of years from the Big Bang until mankind arrives, versus science that says, no, God did everything in 7 days. How could a person try to, expand on their understanding of the scripture here so that it does not contradict the scientist's conclusion? Maybe they could say that what is the proper interpretation of that scripture? What could you throw out there as the suggested compatibilism between those two ideas? Billions of years for man to emerge, or no, 7 days? How could those two things be reconciled so that they don't even disagree? You maybe have heard, Bible study or scripture analysis that tries to reconcile these two loose ends. And how would that be? The person could say that time might be relative. Good, Eduardo. And people will say that. They'll say, well, where it is written in the Bible that he created it in 7 days, that's just shorthand for however long God really took to do it. And a day in the life of a divine being could be any arbitrary unit of time. It's not necessarily the 24-hour day experienced by humans on the surface of the earth, but it could be on timescales of a vastly greater significance, millions, even billions of years. So sometimes people will refrain from a very literalistic interpretation of scripture to make way for scientific inquiry and conclusions that come later. There's problems still, I think, though, with that, because the only temptation to relax the literal interpretation of scripture is because scientific consensus puts pressure on it. It's not like people 1,000 years ago were saying, but what does that 1 day mean when it's written of in the Bible? It's only subsequent to scientific investigation, which indicates this is false, that people think, let us imagine how can we reinterpret these writings in order to bring them back into a consistent state with the state of science. So you might argue that it's in a way a little ad hoc. Only after the fact is this ex post facto rationalization of the scripture provided. Not that anyone anticipates prior to the scientist's investigation how the interpretation ought to be modified. So wherever you stand, there's a menu of possible options. Some people very much prioritize scientific claims over religious ones where they conflict. Others do the opposite. Some say they're in their different lanes, and some say that they actually agree if you apply the correct type of interpretation to religion. So that's everything I guess I have for us for today. There's more to be said on chapter 12, so there's 2 lectures on this that span today and Wednesday. So Wednesday, when we come back, we'll resume with this. Make sure to come to the live stream. I know that it hadn't been as well attended today as it could have been. And to those that are here, obviously, that's good for you. But know that everyone should be attending these class meetings for the sake of your grade. I mean, you have a quiz next Monday that's only on this chapter. I know sometimes people might just watch it later, but let's try our best to maintain consistency with our methods throughout the semester. I want it to be as close to business as usual as possible. So try to tune in while it's live if you can, and tell your classmates and friends to do the same. But other than that, thanks everybody. I appreciate your help and input. I will be grading the most recent homework that you guys gave, and you'll definitely have a score back for that before the quiz next Monday. So anyways, take care for now. And if anyone had questions or comments, they can always send me by email, and I'd be happy to take them at any time. So have a great one, everyone. Stay safe, and we'll finish chapter 12 on Wednesday then. Okay? Thanks so much. Bye-bye.